Hi, this is our final project, and we are doing classical music generation with error characteristics. Just a background knowledge here. There are four eras in classical music. They are Baroque, Classical, Romantic, and Contemporary. So what we're going to do is we're going to split our dataset into four eras, and we are going to train one model for each of those eras. And why we're doing that? Because music generation is an important task to see if AI is capable of doing creative works like music composing, just as human does. So now there are two main models to build a music generator. The first one is to use the models from NLP field, just like Transformer. The second method is using GANs to generate new music pieces from images. So our approach to implement a DC GAN model has failed. This is because that so for this example, we can see the white points and white stripes are too sparse for GAN to capture the structure of the music. So this is a visualization of a piano music file. So finally, we select the decoder-only transformer as our model, and this is just a quick recap of what the transformer block looks like. So our model consists 6 transformer blocks, and this is another example of decoder-only transformer for text generation. So you can see from the input to the target. But for our case, the main difference is that we are generating new nodes instead of words. So how to convert MIDI files to trainable sequences? We learned that there are 128 nodes on events, means that in a single time frame, a node is either being played or not being played. So we encode this to 388 different events and use them to represent each note of the single piece of music. So this picture is an example of that. So we're going to generate new tokens in the raw format and decode it back to MIDI notes, which is actually playable in computer. So I would like to show you our results. The first one is the classical era music. We also include this romantic era music to build a contrast between them. So you can see that the romantic era music has a greater variety of in pitch, dynamic, and rhythm, which is expected results. So this is our train loss graph to show that our model is actually learned something during the training process. As we use Perplexity to measure how good our model is in translation task, we just use the cross entropy loss here. We have learned the first thing is that how to build a deep learning model to solve something in real life. Instead of doing those homeworks where the training data is being pre-processed and and we just had to fill some function in the stencil code. And also we have learned we have a deeper understanding in model details, just for transformer and DC gain, and we also learned something in music theory. So limited in time, we couldn't do more experiments on different hyperparameter sets, because training a transformer itself is very time consuming, and we spend a lot of time in implementation and model selection. So for future work, we want to build a classical music genre classifier on this. But build this classifier is not going to be trivial, so we're gonna leave it for future. Thanks. That's all we have. All we have here. Have a good deep learning day.